Welcome students to today's lesson, and in this video we're going to discuss something a little bit different from what we did in the previous video. This is about multiplication of the surds. We are to discuss something about the multiplication of the surds. Very simple operations. Remember what I said about the objectives that we are using in order to meet our aim. That's to know how to simplify the surds by the operations that I mentioned. Multiplication, division, light. So here we are to discuss something about the multiplication of surds. It's simply like, how do we multiply the surds? In the previous video, we discussed something about the addition and the subtraction of surds. I know you are able to follow that each time we are given such type of expressions. Now, let us get started. Here with me first, I'll give you the outline of the procedure in multiplication of the surds. And after, we'll look at the examples of which that are there going to clarify our procedures which are indicated on my chart here. Right. So every time we would need to multiply the surds. Please, students, just remember the following. Very straightforward procedures, just only 3 steps. And if you go by which, then things will just stick very well and be able to have the product of the surds as such. Right. The first step that you need to consider each time you are given expression about the surds, the way you are asked to multiply, try to first of all take the step number 1 that guides you to simplify each surd where possible. You need first of all to simplify the surds where possible. It means you'll be given some kind of surds which you need to simplify. Like for example, you might be asked to work out the following. A. Root of 32 multiplied by root of 75, then multiplied by root of a 5. All these are terms that we have in this expression are surds. You can remember by the definition itself what a surd is. So we are here now. How do I multiply a surd that is root 32 multiplied by root of 75, then multiplied by root of a 5? Right. So with this one, we have example B, but first, let us first of all discuss the example A. Right. So the solution of which, by the steps outlined on my chart here, the first step say, simplify each side where possible. It means the surd somehow, by what we discussed that at the time, if you remember, we discussed something about the simplification of surds. You try that out. If you can manage to simplify that surd by the procedure we discussed, do it. But if you can't, it means you did just have to leave that surd as it is. Then you see the next procedure about it. Right. Like say for example, we have here root of 32. Right. So remember what I said. When we are trying to simplify the surds, it is just like amount of considering the term inside the surd. In this case is the number like 32. You need just have to factor that one into 2 values. Or say just find the factors of 32. But remember the nature of the factors. One factor should be a perfect number, and the other one should be a rational number. The same that we apply to 75. And again, if it is possible, with the root of a 5. Right. So here, like for 32, it means in this case, if we have the solution for A, root of 32, if we were to get 2 factors of 32, you might bear with me that the first number that we can have there in 32, there's a perfect number in 32, which is a factor of 32. And this number is 16. Right. You can have the square root of 16. So it means 16 is the perfect number. Right. Then 16 to be multiplied by 2 is the one that gives you 32. So if you can look at the 2 factors here, 16 and the 2, you bear with me that 16 is a perfect number, while 2 is a rational number. Right. So we have got the perfect factor 16 and the irrational factor which is root over a 2. In that case, it means you have simplified the surd. Here we're talking about the first surd here. Now let's go to the next one. We have got root of 75. Can I do the same with the, like the way I've done with the root of 32? You find that yes, that one can do. Like here, if I'm to identify the two factors of 75, one being perfect, another one being a rational factor, you bear with me that the factors of 75 are 25 multiplied by what? By a 3. That will give you 75. So it means 25 is a perfect number because it's coming from 5 multiplied by 5. That's just like the square root of what? 25. And while a 3 is just a rational factor. Right. So in this case, it means we are following, that's a step number 1, where it guides us to do simplify each side where possible. Right. So it means the first two sides is possible to be simplified. Now, what about the last one in this expression, which is a root of a 5? Possibly for the root of 5, I don't think there's anything that we can do with the factors of root of a 5, of a 5. Here, the factors of 5 just remains 1 times 5. But here, we're not dealing with a 1 because 1 changes nothing. So here, in our case, it means here it is not possible to, let's say, simplify the what? The root of a 5. So we have left it like that. So what it means here, I think it is now straightforward being mentioned here. Simplify each side where possible. So root of 75 is possible to simplify like this, and root of 75 is also simplified like this, but root of 5 is not possible. Right. Now, where do we go? Next. Right. So after you have done this, remember what I said. You need now to proceed. Where you can have the root, take it for that factor, but if you cannot do it, leave it as it is. It means that number is just irrational. Right. So, like for example, here, square root of 16 multiplied by root of a 2. It's just square root of 16 multiplied by root of a 2. That's what it means here. So here we can have square root of 16 postspray, which is 4. So it means that 4 will no longer be in the root. So it will come outside like that. But 2, it will be irrational. So that 2, you cannot have the square root of a 2. So it means 2 should still be contained inside the root like that. So 2 is irrational because you can't have the square root of which. Right. Then it goes to the next here. Term, which is 75 expressed in two factors, 25 times 3. Here again, you'll be able to see that it is again possible to do exactly as we have done in the first expression here. So here we can also have the square root of 25, which is a 5. And that 5 comes up like that. And then square root of a 3, it is not possible. So I'll leave it like that. So here I have got a 3 still inside the root. And now for the square root of a 5, nothing can be done there. Just have it a root of what? A 5 as it is. Right. Procedures will follow, and very simple and straightforward as such. Now, having done this, what are we going to do next? The next thing that we do, it will be taking step number 2, which is guides us to do this. Multiply whole numbers together and surds together. This simply means that you look at this stage after you have simplified the surds. Here you find that they just like two groups of terms which are aligned with this surds expression. One is a group of numbers which is mentioned in whole numbers, which are just like coefficients of the surds. Like here we have 4 coefficient of the root 2, 5 coefficient of root a 3, and here we know for sure here is just the 1 here. That's coefficient of what? Root of a 5. So when here they say can multiply the whole numbers together, what it is emphasized here, we're talking of the coefficient of the surds. Right. Which will mean you talk of a 4 multiplied by a 5. Here we can still write a 1, but usually we don't write a 1 there. We can just leave it as it is. But if I'm write still more. For my sake, let me write a 1, but we can forego the 1 itself because I said 1 has got no any effect in the what multiplication. That's what it means here. So once you have done that, you also have to multiply the surds together. So here now we talk of the multiplied by root of a 2, then multiplied by square root of a 3, and finally multiplied by square root of what? A 5. Right. So step number 3 tells us to do this. Right. Next, having done this, proceed with the operation itself by the simple procedure that you know how to multiply the numbers, multiply by the numbers, and also for the surds is what we're going to discuss here somewhere, somewhat. Right, so how do we do it? It'd be just like 4 times 5, then multiply by 1. So what we have here, it'd be just like, you consider the numbers first. 4 times 5, then times 1, you get what? That's 20. So you write that one as a 20. Once you have dealt up with the numbers, we also consider now the surds. So it's more like when you are multiplying surds, you have numbers outside the talk of irrational numbers, like here 4, and here is irrational number 2, and here we've got 5 irrational number, which is root over 3, and also here we've got irrational number 5. Right, so when we are multiplying, it's just like the coefficient outside, the coefficient of the surds are multiplied together, and also the surds needs also to be multiplied together. You don't have to mix like say 4 times 2 and again it will go 5 times 3, not that. Right, see what I've done here, I've just considered 4, 5 and 1, which are coefficient of the surds. Then the next thing, these other numbers which are inside the roots, which are the surds, needs also to be multiplied by themselves together. So here it will mean after I found this one as a 20 from the numbers, then for the surds it will be like a multiplication of them, which can be written like this in one single root as a 2 times 3 and then times a 5. Right. Remember the discussion we had that time when we had a scenario where we had got a root of a number when we were simplifying like 2 multiplied by 5. This was just as good as having a root of a 2 multiplied by a root of a 5, which means a single root can be split as far as we have got factors of the number inside the root itself. So root over 2 times 5 is as good as root over 2 times root over 5. So we are at least capitalizing from that now if I've got different roots splitted, but as far as that is, those are the same roots, it's just as good as coming up with one root as such. And all the numbers inside the roots can just multiply like that. So please, can you try at least also master that type of a skill in the multiplication of surds. So please check on that. Now what do you have here at the end? Then it's the final answer. You talk of a 20. Then after, what do we have inside the root? You talk over 2 times 3 times 6, 5. The answer is what? 30. So here it means we have got 20 root of a 30. So this is our answer to the first example, right? Which we had up there, where we are asked to work on the root of 32 multiplied by root of 75 multiplied by root of a 5. Right. So what we've been doing here is just like the last part where we're just now, if you have maybe like terms that need to be simplified, but in this nature, ours, we are not taking to step number 3. Our example just end at this moment where we need just to simplify just by multiplication. That's all. But we may have some questions where we might need us to proceed beyond this. Like we may have like surds where if you have got that type of scenario, you need at least consider step number what? Number 3, like that. Right. That's it for example A. Can we now have the last example on the multiplication of the surds and see how it works? Right. The next example comes in like this. Work out the following. Right. This now is more like an expansion. Root of a 3 plus c square of a 2, and then we have got root of a 5v, and then plus c root of a 7. Right. Root of that talk of a 3 plus c root of a 2 multiplied by root of a 5 plus root of a 7. That is our second example. Right. I would like us still more to observe the same procedures. Are they applied again the next category of the example? Right. So this is expansion. Right. So if a question comes like this, you don't have to be wise. some presentation of the work itself can at least guide you on how best you can handle it. So by just the nature of the outlook of this problem here, you are already there in Form 2, where you were asked to expand the what? The brackets. So we're going to buy that same what? Skill in here. But additionally, we'll just have to have new skills that will help us to operate the SAT themselves. But what we did about the expansion of the algebraic terms, those are the procedures that we're going to apply here. Right, what do I mean? For example, from what we have here, if we are expanding root over 3 plus root over 2, then by root of a 5 plus root of a 7. What we do here is just like every term in the first bracket has to be multiplied by every term in the next bracket. Those are the things. Terms in the first bracket multiplies terms in the next bracket. Right, but what we have here is just like now I'm working on the SATs. How do I multiply these SATs? Here are the 3 basic steps to follow, or just to add on what you already know about the expansion of the what? Of the terms in the brackets. So here we go. Look at this. Right. Here, I talked of every term in the first bracket multiplies every term in the next bracket. So it'd be like, I'll consider root over 3 first. Here I write root over 3, the first term, multiply the term in the next bracket, that will be written like this. Root over 5 plus root over 7. Then I'll go for what? That's a positive root over 2. This also will be written in the similar way they have indicated the root over 3. So here I have got root over 2. Product by opening the bracket, root over 5 plus root of 7. Right. Now from that, where do I go next? Is that what you know about what you did in what? GCA. But here, just like now, how do I multiply? Because when it be here, you'll be able to tell me that this term should multiply by that. That is true. And this one by that. That is true. And then this by that. That is true. This by that. That is true. That is expansion, removing the brackets. In that case, it means now you are going to go straight into talk of the step number 2. Because for step number 1 here, it's just telling us to say where possible. If you feel you can simplify the stats, you can do it. But now if you can try to at least observe each and every stat that is written in this expression, you find that there's now where you can what? Simplify. You see here, we have root over 3, root over 5, root over 7, root over 2, root over 5, root over 7. They're all irrational factors which cannot be simplified further. So in that case, you have the student to have to use your mind. Use your mind to consider the steps here. Which steps do I use? It doesn't mean that always when you give you the step that all the steps are using at the same time. No. But wherever you are somehow, you need some kind of application of the skill, pick up which step can be used. Sometimes you can start right away from the beginning and go up to the end. Sometimes you may just need only one step there and use up, working out the problem. So it depends with the type of problem that you are given. So here we are going to forego step number 1 and go straight to step number 2. Where we need each about the multiplying whole numbers together and SATs together. So here we don't have whole numbers, which are the coefficients, as it was in the first example. Now what we're going to do, we just go for the multiplication of SATs together. Right. So here it will be like a SAT multiplied by another SAT. So remember what I said, a SAT and a SAT, it means we talk of root over 3 times root over 5. This will give you something like this, root over 3 times root over 5. Then it be plus root of what? Talk of a 3 times root of a 7. Then on in this part here, you're expanding, multiplying this by that, you have got plus root of a 2 times root of a 5. Then this against the positive, another positive, root of positive root 2 times talk of the positive root 7, it'll be the same. You're going to write again positive root of a 2 times 7. Forming one root aside. Now what do you do there again? Just multiply the numbers inside. You're done. So here it means like root over 3 times root over 5. This gives you root of 15. And here you have got root over 3 times 7. You have got what? Positive root of 21. And here what do we have? We have got 2 times 5 in the root. We get what? Root of a 10. What about here? You also have the same scenario. We talk over 2 times 7, and this gives us what? 14. You see, such are multiplying by each other. Talk of 3 times 5, you get 15. 3 times 7, 21. 2 times 5, you get a 10. 2 times 7, you get 14. So if we had some numbers outside here, definitely those numbers outside the root would have also multiplied by themselves. Would have also been indicated as coefficient, but here we don't have. So it means we leave it like that. Now, having done this one, it's now going to check the last step, simplifying like terms or like surds. But what we said in the first instance, when we were discussing about like and unlike surds, let's connect the ideas here. We said like terms or like surds are all those surds which have got the same irrational factor. Here we're talking about a root, a number should be the same throughout across the board. But if now we can analyze this, you find that this one is irrational number, but it's a root of 15. This is root of 21. This is root of 10. This is root of 14. Definitely. If you can apply what we've been doing in the algebraic process, this is as good as writing any other kind of expression, but with different variables. Like say, for example, one can write a plus b plus x plus y. That's what it means there. So we cannot manage to simplify such type of terms in algebraic processes. But now what we do here, we also do the same. Because this, and that, you can see all of them are different irrational numbers. So what we do there, it means as far as we cannot manage to simplify this and we conclude this as our answer, so also do the same, that this one also is our final answer, meaning that the expression cannot be simplified. So that's it. Had it been we had some irrational factors there, irrational numbers which are the same, would have done the same, would have simplified them. Like say, for example, I've got 2x plus maybe talk over 3b, then minus maybe x plus 4b. I would have paired this and this, simplified, that and that, simplified. But we don't have such type of scenario there. Right. So this ends up our business today. So I have hope that the two examples that we have just had in this video are possibly very well explaining in how best we can multiply the surds. Somewhere we can have expressions which may demand you to expand, like in example 2. Somewhere we may just have simple terms in the surds, like in example 1. So all those kinds of problems that we might meet where they may ask you to multiply the surds, those are the operations in all angles. Either it be word problem, you may give you a word problem, sometimes direct problem, but where they emphasize the multiplication, please consider step number 1, simplify each side where possible. If you cannot, leave it as it is, then multiply the whole numbers together and surds together. I think you can be able to check what we've been doing here. And lastly, simplify the like surds if possibly they are there. If not, just leave it the answer as such, as we have done in example B. Lights. Before I leave, you need to have at least a trial exercise to check if what we've discussed here is really making sense and you have really followed it up. So can you have this trial exercise? Right? Evaluate. That's 2 root of 5 minus 3 root of a 3 product 2 root of a 5 plus 3 root of a 3. If you're going to manage to work this one very well and find the answer to which, then hopefully now we are together. Right, we'll meet again in the other video where we'll be discussing about the conjugates of surds. Remember, if you have not maybe followed something, just check the link that is down here. You'll be able to follow what we've been discussing. And it's very good if you can do that for the logical purposes. Thank you very much.